Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 131. Ooh, block placement queries. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So, first of all, I know that a lot of people are watching this for kind of for more difficult problems. People always ask whether this is going to be on an interview. And my answer is probably not. I mean, who knows in the future? So if you're watching this really in the future, this is the year 2024, double checking, yep. So if you're watching this really in the future, then I don't know. Who knows? Maybe. But for now, I would say no. And I always have the caveat with Indian OAs, online assessments. Sorry, Indians. I don't know. I mean, maybe, but yeah, sometimes you're just lucky. And one reason why I say this is because this requires, as far as I know, as of this recording. So maybe some people did it because a lot of people did it much quicker. So maybe there's a smarter way. But as far as I can tell, yeah, as of this recording, you need segment tree to be able to solve this. And yeah, it's heavy machinery. It's a little bit silly, but if you ask me, because I think if you understand segment tree, and it does require a little bit of understanding for sure, but if you understand segment tree, then it is just a template. And once you have the template, everything is pretty straightforward. That said, maybe not that straightforward because I got two wrong answers on silly mistakes, but I was focused on it's one of those paradox where you focus on the hard part and then you just kind of, a little bit loose on the easy parts, and then you're like, well, mistakes were made, but yeah. But yeah, so I'm not gonna go over my seg tree. Oh, what the? I think I tried to use something else. Let me, because I was playing around with binary index tree as well, but I couldn't get it to work. So let me get my code real quick. This is taking forever to load. But yeah, but as far as I can tell, this requires segment tree. Let's see. I mean, so I want to say that I don't think this is easy, but it is simple if you know segment tree. So, and the thing with segment tree is that I don't know that I would recommend learning unless you're very strong in a lot of other stuff, right? It's just not that interesting for a lot of people, but like you probably get more rating benefit or just be better if you work on more fundamental things. But in any case, I'm not going to go over the segment tree code. To be honest, 90% or even more is generated by ChatGPT, so it is a little bit template. The reason why I use ChatGPT is because I've used it before for segment trees and it seems to work okay. Don't take my word for it. If it screws you, my bad. But yeah, so I'm not going to go over this, but the segment tree portion in that much detail, but basically it is a segment tree with range updates, kind of lazy range updates, and point queries, right? Okay, so if you want to Google that, you could learn more about this. But the idea here, the key part about segment tree is that it gives us two things, right? Which is, well, range updates and point queries. So range updates give us update a range to a certain number, and point queries actually allows you to get queries a range for the max number. So thinking about this as a black box, that's all you have to know. Like I said, I mostly thought about it as a black box. I have to make minor adjustments, which you can see in the live portion, but that's the idea. And then now, once you have this data structure, then it just becomes. Let me actually bring up the drawing real quick. So then now it just becomes, okay, let's say you have, let's say this is 0, this is say 10, it doesn't, we start with 10 as the infinity. And then the idea here is that, okay, once you start chunking it, let's say we add an obstacle here, then now this is going to be 2, this is going to be 8, and then now we add another one here. Well, we know that this is, this is 2, right? And then let's say we add another one at 6, right? Then we know that here, this is going to be 4, this is also going to be 4, and you calculate it. And then when you do queries, so the splitting up makes sense because you're only going to, this is the only way you could keep on adding obstacles, right? There's no way to remove obstacles, so you don't have to do anything too fancy. Though if you did, it's not that bad conceptually anyway. But yeah. And then the queries is just querying, okay, because it's always from 0, so it's going to be 0 to x and go, okay, what is the max piece here, right? So here, then now we know that, so the way that I did it and why I had a sorted list is because, well, we don't, okay, we don't want to get, for max piece of this range, this part is going to return 2, this part is going to return 4, and then this goes to 4, right? But of course, if your max piece is just going to here, you don't get the whole 4. So what I did is that I maintain a sorted list data structure, so I only get the previous completed in the row, so then now it returns 2, and then just do the math, because here you can do an easy math of this is size 2, right? So something like that, and that's basically the idea, is just breaking it into these pieces for me anyway. The content is just completed, so I might take a look at some code afterwards. But yeah, so this is segment tree and this is sorted list. And once we have this data structure set up, it's and I set up some sentinels at 0 and max, it is pretty straightforward. It's just using the library, which is why I don't consider this a very good problem. I think a lot of it is just a library thing. And I mean, I say that and I got 2 wrong answers, so, but if it wasn't a library thing, maybe I could have thought about all the edge cases. I just wasn't thinking about it. But yeah, but basically here we binary search for the next index, right? Because this gives us the next obstacle after x. So then here, this gives us the next obstacle. So then index -1 gives us the previous obstacle, keeping in mind that we always have 0 to lean back on. And then we update the range from previous to x, to the size of x minus previous, x plus 1 to next, the size of next minus x, right? So then you just kind of divide them into 2, and then now you update the range, the size of the ranges. So this, and of course you add the obstacle to the sorted list. So this is for the update query or add obstacle query. For this one, you don't even need this, I don't think, but I just kind of put it in there just in case because I got a wrong answer anyway. So then now you have an index is equal to this -1, right? So basically this gets the previous the previous obstacle, and then we set the obstacle is, well, this is the index of the previous obstacle, this is the actual obstacle, and then we do a query to get the max out of that, and or x minus p, which is the remaining chunk leaving on, right? And that's pretty much it. We return the answer, and yeah, this is kind of expensive, but everything is log n, to be honest, with lazy propagation. This is log n, this is log n, this is log n, or log max, sorry. So maybe depending on how you want to phrase it. Well, max is going to be 5 times 10 to the 4th. So yeah, so this is, I lied a bit. So this is log n, but this is log max, and this is log max, and so forth. So yeah, and log n, log max, and everything is fast enough. Yeah, that's all I have for this one. I know that I didn't explain that much about it. Oh snap! Sorry, I just realized that my finger's here. So let me go over it way quickly again. Um, sorry, you have to skip ahead. But yeah, so going back to the code, yeah, we have segment tree, we have a sorted list, we add 0, we add max, and then here, as I said, we do a binary search for the next obstacle. So this is the next obstacle, this is the previous obstacle. We can intersect anyway, or there's no duplicate obstacle, so we don't have to worry about anything like that. So we just add, and then we split it. We add it to the obstacle list, and we split it to left side, right side. This is the size, this is the size, and this is the range, right? And then, so that's the update query, add obstacle query. And this is the query, which is, you get the size, you get X, we get the index of the obstacle, we have the obstacle location, we get the query. So this gives us the max up to the previous obstacle, and this gives us the remaining chunk. And that's pretty much it. Pretty straightforward. I know that I went a little bit fast, but still, I think that once you understand the libraries, once you know that you have these libraries and have these templates, it is pretty easy, which is why I don't like this problem. Because, this is the most of the code, as long as you have the proper libraries and templates. I don't know. I would say that's all I have with this solution. And again, my segment tree I got it from ChatGPT, so I'm not gonna go over it too much. This is with lazy propagation. I'm not gonna go over that because it'll take forever. But yeah, the contest just ended, so I want to see what other people did. Let's see. So he did it with seg tree. This is also a seg tree. The number one person did it with a lot of something. Also seg tree. It's lazy seg tree or just regular seg tree? I don't know. But yeah, okay. So I thought maybe there's a more clever solution, but also maybe not. Oh. Oh. People have some crazy templates. But yeah, all this is templated code. So yeah, though they didn't. Yeah, I guess they didn't. Yeah, everyone just did it with seg trees. To be honest, like if you could do this watching the thing. I think I got this with seg tree way early on, but I thought maybe there's a way to do it without seg tree. So I wasted a lot of time in the beginning just trying to do it without the seg tree. I am not a smart boy. So yeah, that's all I have for this one though. Let me know what you think. Let me know if you were able to do it without segment tree. And yeah, don't feel so bad if you didn't get it though, because like I said, this is just a segment tree thing. Apparently you don't need the lazy range updates, but I'm gonna leave it for now. That's all I have for this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve it live during the contest. Now, remember it's a little bit long. You can fast forward some of it. So yeah, bye bye. And it's pending now. Silly mistake. And this thing. Hopefully, okay. Q4 is a little bit hard. People haven't finished it yet in 7 minutes. Otherwise, I don't know. Really bad contest. But still might be bad, but maybe not pretty bad. All right, let's see. Queries. The 2 types of queries. Why didn't I read the constraints? Whoops. Oh. X. How am I thinking about this? Actually read the constraint this time. Just seg tree. That wrong answer has actually been really offensive. That's not good. So many people, because it means that the Q3 is going to be, the 5-minute penalty is very expensive is what it means. Especially if this one's not solvable. 8-pointer. What a silly mistake. Alright. X is 5 times 10. Is it sig tree? Think again, think again. You have all the things. Yeah, that one wrong answer is actually really expensive now, because Q3 is not that hard. Yeah, so many people got it, and it took me 12 minutes in penalty. So I gotta finish this one to do well. I don't even have any ideas. Prefix. Range segment tree, maybe? But people have gotten that, I feel like, but I don't know. Lazy propagation, it's kind of hard. Yeah. 2 people got it finally. Yeah, okay. But let me try. This is from GPT. State tree. Update range is the part that I have to figure out how to do. Because we don't want to just a regular update, we want to update it to the first node, right? It's almost like a min. Okay. Can I even do it this way? This looks right. Okay, fine. So we want to set, what do we want to set? We want the value to be where the obstacle is. Does that work? want that. We want lazy to be to start? No. Well, no, I don't think I could split it up quite like this. Because then you have to do tie breaking in the laziness. People have gone it though. Am I just doing something crazy? I mean, probably. I have to do it another way, but I think this is also fine. Maybe. I think this works. Maybe it's a little bit slow though. Yeah, the variable queries are kind of annoying. Oh, whoops. And then just the next thing, and then X. After that X, so that's wrong anyway. That should be okay. No, the other way, I think. Maybe that's a little bit off, but it's fine. Something like this. It may be wrong though. I mean, maybe off by 1. I'm worried about this +1, to be honest. Well, looks like I should be worried about a bunch of stuff. Oh, I don't want to add stuff. Zero and two. Okay, that seems right. That doesn't seem so good. But that's because I set this to infinity somewhere. To be negative infinity, maybe? I don't know. Well. Sig tree again. I don't have a good template. This should at least be one, actually. Oh, okay, this is just one, but still. Okay, so at least that part's fixed, but still 0 and 2 should now return 0. Update 3.0. Okay, no, that's right. What? Larry, you're terrible naming. True, oh, force true, force. Alright, we can work with that. Axis 12 is probably not right. We update, okay, that sounds right. Maybe that sounds right, maybe I'm off by 1, but it should be mostly right. We query 0 to P. 7.6, max is 12 is probably not right. Why is max 12? Alright, at least that's good. So to P, why is max 12? Oh, I'm doing the addition on this update. Okay. 4. That should be true. Okay, I mean, all right, this is not right. Oh wait, no, that's right. Okay, well, just YOLO then. I don't know. X plus 1 does worry me though, but yeah, if I get a wrong answer, I could use it to figure it out. But it might also time out, so we'll see. If it times out, I'll be a little bit sad, but at least we're on the right track, maybe? I don't know. That took way too long for a silly thing. Why is that wrong? I'll put true, force, 4. Oh, what is that? I mean, I know that it's because the size is bigger than X, but why is max 4? Like, we could hard code this, but 0, 1 is gonna be 4. Well, what's P? P is 0. That's more consistent with what I want. But why not add an if statement as well? Is it still? Okay, yeah. Silly mistake. Wow. Also, well, let's see. I expected force 1, 5, 13, 14, and okay. So then 8. It's gonna be force. Okay. Why did I return true? 5 and 13 is not true. Am I confused? Am I misreading this one? Oh, from 12, I see. Oh. I am dumb, but okay. 13. Wait. I see. Because this returns 7, but the max. Wait, what? The previous is 5. So this returns 7, which is correct. Then why is this giving me? Maybe an off by 1? Yeah, this is giving me 8, but why? We're just going from 0 to 5. 0 to 5 should not be 8, right? Silly mistakes. 5 to 13. Okay, so that's wrong. I mean, this is... I'm just not consistent, I think. I mean, it's fixable. I have to figure out how to be definitive about it. Alright, double check the current things. Nope. Why is this max 3? Because this query is wrong. Because we... update 0 to 2 to 3, which is definitely wrong. Oh. Because of this thing. Wait, what? Was this always the case? Oh yeah, no, this is just because this thing. Yeah, we could skip 0 anyway, right? Maybe. Yeah. 0 is such a weird case. What was the answer for this one? It is force because of size. Okay, yeah. Alright, let's try again. Judging takes so long. If I get a time limit now, I'll be very sad. Because, okay. But, yeah, I mean, I did pretty poorly. Oh, yeah, give some props. A lot of people did well. Maybe I'm missing an obvious solution. The Chain Man, congrats. Joseph, congrats. Drunk Templar as well. Alex. A lot of people solved it, huh? So yeah. I thought it would be a little bit. I mean, this penalty is the one that I was very sad about. But and I got 2 wrong answers on this one just because. Yeah, off by once. Yeah, I just wasn't awake enough. Good job from people. I'm really wondering if there's a simpler way. I mean, I did spend a good amount of time thinking about it, but I feel like lazy propagation with segment tree doesn't seem like a good idea. But maybe there's a smaller way of doing it. Well, definitely could do it with prefix trees. Now that I kind of rethink about how I'm doing it now, because I was trying to do it without using sorted lists, but now that I'm using sorted lists, this doesn't need to be a segment tree, so maybe that makes it a little bit easier. But maybe I should upsolve it. I don't know. Yeah, why not? Can I get range update? What's it called? Prefix, not prefix tree. What the hell is it called? What am I thinking of, Larry? Larry. Binary index tree. That's the one I was thinking of. Yeah, okay, I got the binary index tree. Oh, it should be prefix max, that's right. Update to use max, please. ChatGPT is okay if you know what you're expecting, and I'm just too lazy to copyright the templates. But all right. What? No, not. Okay, well, it's just telling me to use segment tree. Even ChatGPT thinks I use this segment tree, so okay, fine. Let me double check the timing. But, just I could have been faster. The one of the, well, at least one of them wrong answer. Wow, I don't know. At least one of the things were silly mistakes. But I think you could do a range max. On. Yeah, I don't know, whatever. Yeah, I mean, I mean, I'm less caring about the one mistake now, just because. Well, I mean, I got 2 here. If I didn't get 2, that would have been really bad. But I didn't even get top 50. Even if, I mean, so many people beat me. Even without the wrong answer. That's kind of impressive. Guess I wasn't awake enough. I'm also just trying to think whether there's a more fundamental way of doing it, but I've been thinking about it for like 20 minutes for it. I don't know. Yeah, I'm also just trying to. So right now, because my code runs in 9 seconds, I'm kind of just double checking a little bit. But I don't know. Yeah, I'm trying to see whether I can optimize this a little bit before I call it a day, just because. Yeah, that would not be Gucci. Be honest, without writing this like iteratively, it may be a little bit hard. I mean, like maybe I could get rid of some of these, but that's fine. I don't even use build, but that doesn't change the code, so I don't know. That's crazy though, that this takes like this long. I'm gonna convert it to Java just in case a little bit. I don't even know if this will convert to Java, but probably not actually. Just because I don't know how sorted list works. I don't even know how it works in C++. Let's see if it gives it to us in C++, and then we'll resubmit just in case. And then I'll call it a day. How did I copy this code? Okay, there we go. I don't think I need to do any int long craziness. Give it submit. Alright. I mean, this is so much faster in C++. I mean, obviously, the constraints are different, but hopefully, it gives us less room or more room to work with. But yeah, I don't know. It's not that interesting of a problem, to be honest. Once you like, I was trying to spend a long time. Uh, Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.